Okay, one note on sinusoidal motion. This does not mean it has to be in terms of sine. When we write an equation here, it can be either sine or cosine. Cosine is just a shift of the sine curve, so we can use either one, whichever one seems to make the most sense. Okay, so this is one of those problems where we want to find, for the situation, the amplitude, the period, the b, angular velocity, the horizontal shift, and the k, which serves as our center line. So let's start collecting some information. At 2.5 seconds, the spring is at the minimum from the floor. So I'm going to start sketching the situation at 2.5 seconds. So here's 1 second, 2 seconds, 3 seconds, 4 seconds. 2.5 seconds, we are at 1.5 feet. And the maximum is 6 feet. So here's our first point, 2.5 seconds. We're at the minimum. At 3.75 seconds, the spring is at a maximum. So here's 3.75, approximately right here. We are at a maximum. Okay, so what is the period? How long is it going to take to go all the way? Okay, so it looks like it takes 1 1/4 of a second to go from the lowest point to the highest point. So if we double that, means a period of 2.5 seconds. It takes 2.5 seconds to go all the way up and come back down. So I'm going to put down 2.5 for the period. Now let's see about our amplitude. Our amplitude is going to be half the distance from here to here. So 1.5 from 6, we've got this total distance is 4.5, so half of that, 2.25. 2.25 amplitude. So where does that make our center line? 2.25 above 1.5, so I'm going to add those. 3.75. It's our center line, so that's going to become our K. Now I just need to calculate B. 2.25 times B equals 2 pi. Divide both sides by 2.5. Alright, so I'm going to double both of these to make it no longer have a decimal. So that leaves me with 4 pi over 5. Four pi over 5 for my B. Okay, we're almost there. So, what kind of equation do we want to make? I can do a negative cosine using this point right here, because cosine starts at a maximum, but we're at a minimum, so we could do a negative. So I'm going to go ahead and call this my height is going to equal negative my amplitude, 2.25, times cosine. Now for the B, 4 pi over 5 t, my time in seconds. And my horizontal shift, let's make that shift the same as the first point in time we started timing, so 2.5 seconds. So minus 2.5 and plus my center line. Okay, now let's look at the questions that we have. Find the height of the spring from the floor at time 3 seconds. So that's going to be about right here. Okay. The period of this is 2.5, and we started at 2.5. So if I do one more curve backward, we actually start at time 0 at the height 1.5, which is awfully handy because I can change this equation a little bit and right here find the first 2 times when the spring is 2 feet from the floor. Well, I'm pretty sure that's going to occur here and here. So I'm going to adjust my equation a little bit. I'm going to change my shift to 0 and still do negative cosine. So I'm going to put 0 right here. So that makes this h is equal to negative 2.25 cosine of 4 pi over 5 t plus 3.75. So let's go ahead and solve for time 3 seconds. Substitute 3 in for time. So I don't have to write it again. I'm just going to copy over that. Let's pull up the calculator and work this out. So I've got 3 times 4 makes 12, so 12 pi divided by 5, and take the cosine of that. Cosine, insert the previous answer, 0.3. Now let's multiply that by our negative 2.25 and add 3.75. And voila, our height is 3.055 feet. Okay, now it's time to find the 2 places where the spring is 2 feet from the floor, so we're going to substitute that for height. So my height is 2 feet, and so I've got 2 is equal to negative 2.25 cosine 4 pi over 5 t plus 3.75. So let's subtract 3.75 from both sides. And we got negative 1.75. Then we're going to divide that by negative 2.25. So that equals the cosine of 4 pi over 5 t. Let's pull up the calculator and work on this. Move that over. Oops. There we go. So I know this is going to come out to be positive, so I'll do 1.75 divided by 2.25. Now I need the inverse cosine of that. So inverse cosine of my previous answer 0.67, yada yada. And then I'm going to multiply, I'm going to undo this from the t. I'm going to multiply this by 5 and divide by 4 pi. And we get 2.6696 as one of them. So let's minimize that. We get time is equal to 2.2296 seconds for one of them. Well, that would be the second time. So I need to figure out what this value is. And I'm pretty sure that we are the same distance here to here. My very first point in time was 2.5. So I'm going to do 2.5, subtract this one. And this distance is equal to this. I'm pretty sure I'm going to find my other value. So back with the calculator. 2.5 minus my previous answer. Okay, I found an error in my calculator work. I didn't put the 4 pi in parentheses, so it divided by 4 and multiplied by pi, but I need it to be divided by both 4 and pi. So my actual answer is 0.27. So back to this. This is not the correct output. My time is my first time, 0.2704. The first time, and then I need to figure the last time. So we're going to do 2.5 minus 0.2704. That will give us our second place that this occurs, 2.2296 seconds. Whew. Got through it. Okay. On to the next question. See you in the next video.